Hi guys, and welcome back to my C++ for game development series. And in this part we'll be taking a look at vectors and we'll also be doing a basic implementation of them in C++. Now a vector is basically a representation for anything that has both a magnitude as well as a direction. So this is going to be of very less significance for us. However, this is just a conventional representation. What I've drawn on the screen is a vector, and the end over here which does not have the arrowhead is called the tail, and the end which has the arrowhead is called the head of the vector. And you would label the vector a little something like this. However, this is not that important as I told you guys previously. If you were to notice, due to this arrow over here, this vector will have both a magnitude as well as a direction. Now the magnitude of this vector is simply the length of this line basically. This is going to be the magnitude of the vector, whatever I've drawn over here. Now, how do you actually find the length of a vector? Now, to find the length of a given vector, what you do is you would use this equation right here. So your magnitude, you would represent that with a modulus symbol. So magnitude of the vector AB will be equal to the sum of the squares of the x component and the y component. So let's say this is x and let's say this is y. And this is pretty obvious, I guess, how we actually got this. This basically from the Pythagoras theorem. We basically derived it from there and we can find out the magnitude of the vector. Now, in order to find the direction, generally we will be comparing vectors relative to each other. Generally, we don't actually talk about the absolute direction. But anyways, in this case, we'll just take the direction of this vector with respect to the horizontal. Generally, you will compare two vectors. So let's say you have a vector like this and you have a horizontal. And let's say this angle is theta over here. And let's say this is vector A and this is vector B. So the way you'd find it out is, first of all, you'll be normalizing the vector. And there is a concept known as dot product which you'll be using to find it out. Now it's represented like this. So if you want to do the dot product of any two vectors A and B, so you'd represent it like this. The dot product of two vectors will be equal to the magnitude of A. So obviously we are talking about the magnitude of the dot product, and dot product is a scalar, so it doesn't matter. So it's going to be the magnitude of A into magnitude of B into the cosine of the angle between them. So this is how you are going to be finding out the dot product. Now, if you were to notice, if you were to require the angle, you would somehow have to isolate cos theta. The way you do it is by normalizing these vectors. This is the general approach. You can obviously divide it by the magnitudes as well. That's totally fine. And obviously by normalizing it, you are doing that. So what I mean by normalizing is making the magnitudes of A and B 1, but at the same time, we want to retain the direction. So the way we would do this is, let's say we have this. The length of B is going to be the exact same as A, but it's going to retain its direction. So you'll just denote it with a cap, but anyways, that doesn't matter for us. So let's just proceed. So now our magnitudes are 1. So now in this case, so if I were to consider this, you're going to have the dot product of A and B is equal to 1 into 1 into cosine of the angle between them. Now easily you can get the angle between them by inverse cosine of the dot product. So this is how you'd get the angle between them. So this is a basic operation which you might want to do on vectors. So how do you actually get the dot product? It's fairly simple, and you will understand how to do that once we actually get into the implementations. There are built-in functions to just directly find the dot product. Now, a dot product, you generally find it by multiplying their corresponding components. I will show you guys how to do that in the implementation part. Now, similarly, you also have a cross product, and for the most part, right now, we'll just talk about the magnitude of the cross product, and also I'll just show you guys how to get the actual, result of the cross product. Now, intuitively, this is what you need to understand by cross product. And before we do that, you need to know that a vector which goes inwards is represented like this, and a vector which goes outwards from the screen, I'm saying, is represented like this. This is because our screen is in 2 dimensions and we cannot really represent 3D vectors. So let's assume that we have a vector like this. So we have 2 vectors like this. So let's just clear this part out. So we don't need this anymore. So we got to know what's the dot product. Now what we can do is we can go ahead, and the cross product is basically going to give you a vector perpendicular to any 2 given vectors. So let's say you had a vector like this, and let's say you had a vector like this. So let's just call it A vector again, and let's call this one B vector. Now the result of A cross B, so the cross product of A and B, will give you a vector which is perpendicular to this, and you might use it quite often. So let's say you want to find the normal of a surface where you have 2 dimensions, you can use it, stuff like that. So these are just a few operations. Generally you would use these and maybe a few others. So A cross B by magnitude. So here I have to use magnitude because the result of this is a vector. So the magnitude of A cross B is going to be the magnitude of A into magnitude of B into the sine of the angle between them. And we will actually take a look at A cross B as well. Now vectorially, the result of A cross B, and I will write this separately. So the result of A cross B will be a vector like this, and the magnitude of it will be equal to this much, A B sine theta, and the direction of the vector is outwards in this case. So how do you actually get it? So if you want to talk about the actual vector form of A cross B, this is how you do it. This is how you do it mathematically. This is of very less significance, so I'm just going to show this to you guys. So I is basically your x component, y component, and k is your z component. And you are going to have the x component of the first vector over here. So let's represent our vectors like this. So let's say this is ax I plus ayj plus azk. So basically I've broken the vector down into components. It's the same thing what we did over here. So as you can see, we broke it down to x and y components. So for example, in this capital AB vector which we have on the left, the x component is going to be x as per what you denoted, and the y component is going to be y. So for this vector, let's just assume it's ax, ay, and az. So B vector is going to be bx, and so on. So it's going to be ax, ay, az, and this one is going to be bx, by, and bz. Generally, to find angle between 2 vectors, you generally don't use the cross product, you will use the dot product generally, but this is how you do it. So you'd have to solve this determinant in order to get it. So it's going to be I into ay bz minus by az minus j into axbz minus bxaz plus k into axby minus bxay. Anyways, this is not a notation which you will actually use. So this is the basics of vectors. Basically anything which has a magnitude and direction and you'd want to perform an operation on it, you would basically use vectors. So for anything which has direction basically, because everything in games at least will have a magnitude. Alright, so let's head into C++. Alright guys, so now we are in C++ in Visual Studio and we'll be implementing our vector over here. So for that, let's go ahead and create a new class first. So right click on any one of these filters or folders, new item, and just click on C++ class. And we're going to be calling this one vector3. So vector3, click OK. Now that we have our class over here, we can start by setting up the members. Now obviously for the members we will need the components of the vectors in the x, y and z direction. So the I, j and k component if we consider the return notation. So we'll call this one x, y and z over here. So under the private section we are going to make 3 doubles. You can use float as well, x, y and z. Now since these are private, if we do need to get each of the members, we can create a function to just get them. So under the public section over here, let's just create 3 functions called get x, get y and get z. So what we're going to do is we are going to be writing a function which returns a float or a double get x, and it's going to be const since we don't want to be modifying anything in the class. So if you use const, basically it means you cannot modify x, y and z or any other member for that matter. So we are going to return x. So we can just declare it in line like this. Same for get y and get z. So get y and get z. So for this we'll be returning y and we'll be returning z over here. Now one thing to note is that we can't actually set anything right now, as well as we don't have any constructor to initialize this vector or change the value. We will worry about that a bit later, but for now let's actually create a function to find the magnitude of the vector. So we can type, so magnitude is going to be a double again, so double get magnitude, and this is going to be const as well. And we can define this one outside the class, forgot the parentheses over there. And we can go ahead and quick actions, create definition in vector3.cpp. It should take you over here. Now we know that the magnitude is just going to be the square root of the square of the x component plus the square of the y component plus the square of the z component. So what we are going to do is we are going to use the sqrt function for the square root, which is inside our cmath header file. So as you see, we get an error over here, but what we can do is we can simply include cmath. And now we shouldn't get the error. Now it says no overload found. That's because we haven't passed the argument yet. So it is going to be x squared. So x into x plus y into y plus z into z. So this is going to give us the magnitude of the vector. Now also, if you were to notice, all these methods are const, so we can't actually modify any members. Now let's actually go ahead and create a method to actually set this vector. Now we don't need to create a function necessarily. We can create a constructor, and I'll show you guys how to actually use it. So first let's just put the default constructor over there. So vector3, we'll declare this one in line. So if you create a function like this without a return type, this is a constructor basically. So the name of the function is same as the class name, and arguments you can specify or you can choose not to. This is a default constructor, meaning we don't specify arguments. If we do specify arguments, we call it a parameterized constructor. So in the default constructor, we'll just do x equals y equals z equals 0. We'll be using chained assignment. This is possible in C++. Now for the next constructor, we'll be taking in 3 floats, or rather 3 doubles. So double, let's say in x, and it's going to be in y and in z. I'll just copy this over. In y and in z, in y and in z. We can declare this inline here as well. We can define this inline. So we can do x equals in x, and you don't have to go to the next line necessarily. So y equals in y, and z equals in z. So this is going to work. So we basically initialize x, y and z to whatever we pass inside this constructor. Now another function which you might want to use is normalize. Remember I told you how we use it when we are finding angle between vectors. Basically, you are converting this vector into another vector of the same direction but which has 1 as the magnitude, and that is useful in many cases. Wherever you have magnitude, you can neglect that and assume it to be 1. So for normalize, we will be returning the vector again, or you could do void, but I find it very convenient to also return the vector which you have normalized. So vector 3 is going to be the return type normalize, and we are modifying the members, so this is not going to be const. So we can go ahead and create a definition for it, and this is going to be relative to an object, so let it be. Now logically speaking, all you have to do is you have to modify this vector. So you have to do this. So this pointer is going to be the address of this object, while asterisk this is going to actually allow you to get the value. So you can change the members of this object basically. Now you can do something like this. Upon, what you could do is you can do get magnitude, but you will notice a problem here. The compiler actually doesn't know what to do with the division operator because we have not defined the division operator. So now this seems like a problem. So what we can do is we can use a concept known as operator overloading in order to actually overload the division operator for vector 3. So basically you're telling the compiler what to do when it comes to division for a vector 3. So let me go ahead and do that. So the way you declare it is, first of all, return type. Now division of a vector by a number is what we are doing, since get magnitude is going to give a double. So this is simply going to be, scalar division. So the return type will also be a vector, a scaled down vector basically. Vector 3, operator, and then you put in your operator name. Now the first operand will obviously be, your vector 3 itself, and the second operand is going to be passed in over here. So you can pass in a float reference. You could use float as well, no issues. And what you can do, you can use const float reference if you wish. What you can do is you can actually pass in the number which you want to divide. So we'll just type in value. So I'll just do pass by value over here, doesn't matter. And we can go ahead and define it the same way as we do any other function. So as you see, this is color coded differently because this is where we're using operator overloading, and I just realized we didn't return the value over here. So let's just go ahead and return the same vector once again, since that is what we are going to be getting if we actually modify this. Alright, so now what we can do is in the division operator, what we can do is we can return a vector using our constructor that we defined. So inside our constructor we had one which takes in 3 floats, or rather 3 doubles. So we can use that constructor in order to actually return the value. So I'll use double here as well just to be consistent. So I'll use double here. Now if I were to go ahead and do the division, so it's going to be each component divided by the value. So it is going to be x upon value, comma, y upon value, comma, z upon value. So this is going to be our constructor, and I had to put division over here. So now if you were to take a look, this error is gone over there since we have actually defined our division operator. So this is how you basically use operator overloading. This is a good example for that as well. Now another thing which you might want is dot product and cross product. So the way you would do dot product and cross product is a little something like this. So dot product is going to return a number again, so it's a scalar, so double dot product. And one thing to note is that this need not be relative to a specific object, so we can declare that as static, and I will show how to call this function as well later on. So we'll pass in two vectors, used to the unreal notation. So we're going to take two const vector references. So this is going to be vector A, and we'll also be passing in another vector, vector B. So we'll go ahead and declare it. So once you define the function here, what you can do is you can return the dot product. Now the dot product is basically the corresponding components multiplied with each other and summed up. So it's going to be a dot x times b dot x plus a dot y times b dot y. We'll just copy that over, and this is going to be y, this is going to be y as well, and this is going to be z. So this is going to give our dot product, which we can later on use for other purposes. Now if you were to remember, we had also done something known as cross product. Basically, in order to get a vector which is perpendicular to two input vectors, and we can go ahead and create that function as well. So it's going to be of the same format. So this one is going to be cross product. This is useful if you want to get the normal to a surface or something, but remember this is going to be returning a vector itself. So go ahead and create a definition for it. And now what you can do is you can go ahead and define the cross product function. So we have to solve the determinant which we had over there. So let me just open that up. So I have opened up the OneNote file over here where I had returned the determinant. So this is simply going to be something like this. So for the x component, this is going to be I times aybz minus azby. So this is going to be aybz, so a dot y times b dot z minus b dot y times a dot z. This is going to be our x component, and for the y component it's going to be minus of, so it's going to be ax bz, so a dot x times b dot z minus bx az. So if I'm not wrong, bx az, and I will show you guys how to verify this as well if it's correct. And for the z component, it's going to be ax by minus bx ay. Alright, so we can take that full screen. And now if you were to notice, this is our cross product. And now let's actually go ahead and test these functions. So testing these functions is going to be fairly straightforward. And one more thing I forgot to tell you guys is we might actually need another print function since we won't be able to use cout or something like that just as is. So let's go ahead and create a function right here. Let's go ahead and create std string, and let's go ahead and call this function toString. So this is going to be related to this, and we'll just go ahead and include string. So hash include string. We'll go ahead and define that. And over here, what we'll do is we'll just go ahead and return how we want to visually display it. So it's going to be x equals, and what we'll do is we'll just go ahead and print out this one right here. It's going to be x. So x equals plus x. We're just appending the string over here basically. So we can use the toString function for this. This is going to be toString x. So I'm not using namespace std. So std toString x. And what you can do is you can add y equals. So leave a space, y equals. And this is going to be toString y. So change that to y over here. And same thing we have to do for z. So we'll go ahead and do that. So y equals, and this is going to be z equals, and we are going to get z. Alright. Now in our main we can go ahead and create two vectors. Vector 3 v1, and we have to include our vector header file obviously. Hash include vector 3 vector 3 dot h. So it's relative to our solution directory, so we'll go ahead and include that. Now we shouldn't get this error. So we have v1, let's initialize that to something. So vector 3, let's say it's a unit x vector. So we can say v2 equals a unit y vector. So we'll copy this constructor over and we'll make this a unit y vector. Now we can go ahead and test out everything. So we can go ahead and print it. So we are using namespace std here. So go ahead and type v1 dot toString. So let's go ahead and test it out. So as you can see, we get x equal to 1, y equal to 0, and z equals 0. Similarly, we can go ahead and print out the next vector. So let's go ahead and end the line over there. Same over here as well. So this is basically our v1. So we'll go ahead and change that to v2. So as you can see, we get that. Now let's try doing the dot product. So in theory, we should get 0 over here because these two vectors are perpendicular. So we are going to do cout dot product. So this is inside the vector 3 class. So vector 3 dot product, and we can pass in v1 and v2. So we should get 0 over here. So as you can see, we get 0. Now if I were to make this 0 and 1 over here, so both unit x vectors, as you see, we get 1 for the dot product. Alright, so if I were to go ahead and change this to something like 3, we get 3 for the dot product. We can again go ahead and modify this and we'll get different values of dot product. So we don't have any component over here, so let's say 0.54, I just took a random value over there. So 4.08, depending on that, you are going to get something over there. So let's keep this as is. And let's go ahead and actually try the cross product. Now in theory, if you cross a unit x vector and a unit y vector, you should get a unit z vector. Let's go ahead and test that out to make sure our function is correct. So cross product. And we'll need to use the .toString method since it doesn't know how to actually print out our vector. So I didn't end the line over there. So if I were to go ahead and print it out, as you see, we get a unit z vector, which is exactly what we want. So we get a unit z vector when we do our cross product. Now let's actually test out our normalize function. So let's go ahead and do something like this. So we get 3, 0, 0 for our first vector. And what we can do is we can do v1 dot normalize. Let's see what we get. So we get 1, 0 and 0. Perfect. You could do it inline over here as well. So you could do something like this, v1.normalize.toString. You can call functions like that. So as you can see, we managed to successfully normalize this vector. Now this need not be just a vector like this. You can go ahead and change the components which you have. So you can have 2, 1, 5 maybe, 7. Now if I were to normalize this, you will get different results. So as you can see, you do get a normalized vector. And one last function which I want to show you guys is finding the angle between any two vectors. So this is going to be the same as your dot product, the function prototype. So we'll say angle between vectors, and we'll be using the same concept which I discussed earlier. So angle between A and B. So a simple solution to this is going to be cosine inverse of the dot product. So first of all, what I want to do is I just want to create a copy of this just for simplicity. So I'll just do auto a temp equals a. I think it's going to take it as const, or if it doesn't, then that's cool. And b temp equals b. Now what we can do is we can go ahead and modify a temp and b temp to normalize them. Dot normalize, and we can do b temp dot normalize. Now since we have the unit vectors, now the magnitudes are 0, so we can directly take cosine inverse of these vectors. So we are going to return a cos, which is again there inside our CMath file which we imported. Now this is going to be in radians, so we can change it to degree if we want. So it's going to be a dot temp. So it's going to be the dot product of a dot temp and b dot temp. So vector 3. So dot product a temp comma b temp. So this is basically what we want to return. So the cosine inverse of the dot product. And just to make it clear, just so that it's understandable, we can do 180 over pi. I'm not sure if we have a pi hash defined. We don't, so we'll just use the value 3.14159. So this is going to give us the value in degrees rather than radians, so that it's easy to understand. So we can test that out as well by just directly printing it over here. So we can do it after the cross product. We don't need to normalize this. We'll just print it out as is. And what we can do is we can go ahead and copy this over. And we can do angle between vector 3, angle between v1 and v2. Alright, so let's go ahead and test it out. We should get some value over here. And we get some value, but we cannot really verify it right now. So let's go ahead and take something which we can verify. So let's take a unit x vector as well as a unit z vector, let's say. Or rather, let's take another x vector itself. So x vector of magnitude 3 and magnitude 4. So as you can see, we get 0, which is absolutely correct. So what you can do is you can take 1 and 1 over here. So you should get 135 degrees. So you get 45. So this is negative 1 and 1 will give you 135. My bad. So you get 135 over here. And let's go ahead and try something which is perpendicular. So this should give you 0, or rather 90. So as you can see, you get 90. This is due to floating point precision error. That's not a big issue. You can round it off. So that's about it, guys. So that's basically a very basic implementation of a vector. And you can obviously go ahead and modify it the way you want it to. In a game engine, however, all this stuff is already implemented for you guys, and this is basically the principles you would use in order to do computation for your game. So just a quick summary here. So angle between is going to find the angle between our vectors. We defined a few constructors in order to actually initialize our vector. We also learned how to overload operators. So you can do this for any other operator, multiplication, addition, division, so on. We found out how to find a vector which is perpendicular to any two given vectors by using cross product. And we also found out how to use the dot product. And we also found out the angle between vectors using dot product. So that's it for this video, guys. Thanks for watching. If you guys did enjoy the video, make sure you guys do leave a thumbs up. Also, link to my Discord server as well as my Patreon is down in the video description. And I hope to see you all soon. Goodbye.